Hello and good day. My name is RibcaSirah anak Unang. My supervisor for my final year project 2 is Dr. Nurashikin binti Suhaili, and I will be presenting about the effect of inoculum concentration of Rhizopus oligosporus on tempeh fermentation. The content that I will be presenting will be divided into introduction, literature review, materials and methods, results and discussion, and finally, conclusion. Tempeh is an Indonesian traditional fermented soy product made of whole beans or legumes, commonly soybeans. The nutrient-rich soybean is a source of energy for fungus Rhizopus oligosporus to produce hyphae surrounding the soybeans. Solid-state fermentation (SSF) is used, which require minimal water content and solid medium to provide sufficient moisture for fungal growth. Tempeh is regarded as functional food for its increased nutritional value, lower fat content, and antioxidant effects. For home-based production of tempeh, the effect of different concentration of Rhizopus oligosporus using soybeans as substrate is yet to be determined. Hence, more proper studies need to be conducted in order to understand the influence of inoculum concentration on tempeh fermentation. The objective of this study is to investigate the effect of different concentrations of inoculum on tempeh fermentation and to determine the optimum concentration of inoculum needed for tempeh production. The production of tempeh is known for its feasibility, such as low-cost materials, quick and simple preparation. The characteristics of the tempeh include firm texture, nutty aroma, and white-colored mycelium. The choice of beans can be varied, such as soybean, barley, chickpea, or horse bean. The wet dehuling process is involved the soaking of soybeans for dehull and cook in fresh water. Then, inoculation using fungus Rhizopus oligosporus followed with incubation. The lactic acid bacteria acidification occur during the soaking stage, causing the pH to drop to less than 5, which inhibit the undesired growth of other microorganisms beside from Rhizopus oligosporus. There are several benefits of consuming tempeh. Firstly, it enhances vitamin and amino acid content and promoting detoxification. The breakdown of proteins into free amino acids and peptides cause total soluble iron content to increase. Apart from that, tempeh has lower fat content as the triacylglycerol reduced to free fatty acids used as source of energy for the mycelium to grow. And the use of soybeans promote the antioxidative properties through the presence of 3-hydroxyantranilic acid HAA. Lastly, it is also believed to reduce the risk of several chronic degenerative diseases such as cancer. Rhizopus oligosporus belongs to family Mycorrhizaceae, is non-toxic, and has a reduced rate of sporulation. The incubation period of 25 to 37 degrees Celsius causes the growth of white mold mycelium. The enzymes produced during fermentation, such as carbohydrases, proteases, and others, hydrolyze the soybeans component, thus further contribute to the development of the desired aroma, taste, and texture. SSF is used to produce tempeh which require minimal moisture content for the growth of mycelium covering the soybeans. Next, I will be talking about the materials and methods. The materials needed to produce the tempeh is inoculum Rhizopus oligosporus, apple cider vinegar, weighing scale, whole soybeans, and Ziploc bag. There are three general steps involved in the production of tempeh. Firstly is the pretreatment of soybeans, involving the overnight soaking of 400 grams of soybeans, the hulling process, cooking of soybeans, and the addition of vinegar, and the drain off of the water, and then the soybeans left to cool at room temperature. Next is the tempeh fermentation, where 0.74% inoculum added and mixed homogeneously in the soybeans. The inoculated soybeans is then left to incubate in the Ziploc bag. The process is then repeated for inoculum concentration of 1.5%, 2.2%, and control without the addition of inoculum. The analysis include the observation and recorded weight taken at 0, 24, and 48 hours. The analysis using weight of tempeh and numerical rating scale based on physical appearance, scent, and thickness of mycelium. The scale is from 1 to 5. The 1 is very unfavorable, 2 unfavorable, 3 neutral, 4 favorable, and 5 very favorable. Next, I will be discussing about the results and discussion. Table 4.1.1 shows the fungal growth observation on sample control not applied with inoculum at 0, 24, and 48 hours of incubation period. There is no indication of physical changes and presence of white mycelium. The addition of Rhizopus oligosporus as inoculum produced the white mycelium during the incubation. The Rhizopus oligosporus utilized the components of the soybeans for the germination of the sporangiospores by hydrolyzing it using digestive enzymes such as proteases and carbohydrases. When there is no addition of microorganisms to utilize the soybeans' components as source of energy, thus the germination of sporangiospores is not possible to produce the mycelium in the absence of Rhizopus oligosporus. Table 4.1.2 shows the fungal growth observation on sample A applied with 0.74% of inoculum at 0, 24, and 48 hours of incubation period. The presence of yellow color on the surface of the tempeh is caused by senescence phase of fungi and oxidation of unsaturated fatty acids. It also indicates the release of ammonia as byproduct. Table 4.1.3 shows the fungal growth observation on sample B applied with 1.5% inoculum at 0, 24, and 48 hours of incubation period. The yellow stains of the sample B is much more clearer and the mycelium appear denser compared to the replicates A. The inoculum concentration of sample B is higher than sample A, thus fungal population density is higher in sample B. Growth of fungi lead to more enzymes produced to further break down the soybeans components such as proteins into amino acids and peptides. The rate of formation of ammonia is higher, causing the accumulation of ammonia at toxic levels. Thus, the increased concentration of inoculum provides the accumulation of ammonia at faster rate. Table 4.1.4 shows the fungal growth observation on sample C applied with 2.2% inoculum at 0, 24, and 48 hours of incubation period. The sample C has presence of black spots at 48 hours and the thickest mycelium compared to other tempeh. The presence of black spots is due to high levels of ammonium concentration at toxic levels. This caused the inhibition of mycelium growth and eventually lead to senescence phase. The fungal population density is the highest for sample C compared to other tempeh due to highest concentration of inoculum used. The high concentration of inoculum caused stormy growth, rapid increase in temperature, and premature death of the fungal. Next is the analysis of mean weight of tempeh samples at 0, 24, and 48 hours. At 24 hours and 48 hours, both sample A and sample C has the lowest and highest mean weight respectively. The concentration of inoculum affects the fungal population density. As the concentration of inoculum rises, the amount of sporangiospores to germinate will also increase. The high amount of mycelium produced causes the amount of enzymes secreted to also increase. Thus, enzymes allow more components of the soybeans to be utilized as a source of energy to grow. Over time, the accumulation of ammonia at toxic level leads to senescence phase of the fungi as pH levels also increase. The high concentration of inoculum caused the mean weight of the tempeh to increase due to the abundant formation of mycelium. In terms of physical appearance, tempeh A has the most favorable score followed by tempeh B and C. The black spots is caused by the diffusion of ammonia from tempeh to keep it from inhibiting the growth of mycelium. In terms of aroma, tempeh A has the most favorable aroma compared to tempeh B and C. The ammonia-like smell present in tempeh B and C is due to the protein and amino acids breakdown, further lead to accumulation of ammonia. Lastly, in terms of thickness of mycelium, tempeh C has the thickest growth of the mycelium followed by tempeh B and A. The highest concentration of inoculum causes higher fungal population density due to higher amount of sporangiospores present, consequently causing increase in the weight of the tempeh. In conclusion, the effect of different concentrations of Rhizopus oligosporus as inoculum in the tempeh production was determined. The tempeh with inoculum concentration of 0.74% has the most preferable physical appearance, aroma, and uniform growth of mycelium. The results based on the numerical rating scale shows that the order of the most to the least preferable Rhizopus oligosporus concentrations are 0.74%, 1.5%, and 2.2%. The recommendations to this study include a requirement for more controlled environment and the study of the effect of period of incubation or pH on the tempeh mycelium to provide more significant reasons behind the physical changes occur on the tempeh. That's all for me. Thank you.